And welcome everybody to the Daily Space Weather Show. That track is from Golden Cat Productions. By the way, you can find it all over the internet. Golden Cat Productions, our own music label. So yeah, welcome to the Daily Space Weather Show. It's always a delight bringing you the most detailed imagery you'll find in the known universe of the closest star. These are 24-hour videos from SDO. And let me bring up something that, for some reason, is not displaying. What's up with that? Alrighty then. It's a rift in the matrix, folks. A rift in the matrix. There we go. There is a close-up of Sunspot 3590. We've allowed the frame of view to rotate here to keep that sort of stationary on your left screen. It is the T-mass of the day. It will remain the story to follow. Its likelihood of producing large solar flares is increasing as it approaches the solar limb. So, anyway, let's take a look at, these are the past 24 hours from SDO 335 angstroms wavelength. And we'll take a brief moment to pause and take a look down at planet Earth instead. So that's the past 48 hours, and these are the erupting volcanoes. Abiko kicks off the list with a 12,000-foot ash plume, also Subanose Jima, Ibu, Luitolo. Creating some new real estate there is Luitolo. Semeru also exploding. 15,000-foot ash plume, also Merapi, flight level 150. Flight level 220, Popocatépetl. Santiaguido exploding. Fuego. Mild explosions, Nevado de Ruiz and Sabancaya. Please do not pole vault the caldera. It could be unhealthful. Next, earthquakes. And there's been an earthquake swarm going on at Alaska. Also an earthquake drought of 7+ magnitude earthquakes. That puts Alaska on high alert, folks. As Alaska is a very dangerous place for tsunamis. There are a lot of fjords there. So check out the recent earthquake profile there. That's just the last 24 hours. That's a lot of quakes. And of course, when a tsunami propagates up a waterway like this, it has a tendency to amplify the size of those waves as the waterway narrows and gets less deep, or you could say more shallow. Of course, the wave gets larger as the energy is forced upward. So, big earthquake risk there for the Anchorage area, as could be some foreshocks going on there. Anyway, these are the quakes of a 5 and greater magnitude. Not too many. Also an earthquake swarm there in western South America. Those are some bigger quakes than the Alaskan ones. But once again, the boundary there, the Pacific Ocean boundary between the plates that border it, seeing a lot of seismic unrest happening. Could be earthquake foreshocks down there as well, when a smaller event is the predecessor to a larger event. First 5.0 or greater magnitude quake was a 5.3 at Timor-Leste. That was at 4:49 this morning. Then Solomon Islands had a 5.0 at 11:29 this morning, east of there. Then Papua New Guinea, in between there, had a 5.0. So some seismic unrest there as well. Those are the 5 and greater magnitude quakes. And let's get back to space. There is our 171 angstroms wavelength, the house favorite, and let's continue on to look at some space weather stats. The 10.7 centimeter radial flux now at 168 solar flux units. 168 is the radial flux. There's the 1-year graph by Solon.info. 168 is the radial flux. There is the Space Weather Enthusiasts dashboard, and we did have a little bit of geomagnetic storm conditions, but none on NOAA's forecast. So moving right along here to our geospace magnetosphere movie. That's the past 4 hours of Earth from space. In terms of, that's basically what a proton experiences when it shows up in the magnetosphere. That's depicting magnetohydrodynamic pressure there for the past 4 hours. It's calm currently in the Earth magnetosphere, so no geomagnetic storm activity. Here's Earth's magnetic moment from ground level. Magnetic flux density is depicted there. Again, it is the last 4 hours. Pardon our absence last night, by the way. There were some errands that had to be run, and they were pretty urgent, so they got run instead of making this video. Next, the KP index is currently geomagnetically calm, but a little bit elevated there at 2.67. 2.67 is the KP index, an average of geomagnetism. On a global scale, that is. Next, our solar wind data from ACE. ACE looking quite nominal and pretty diffuse for the solar wind as far as Discover. Pretty similar there. It's pretty slow and pretty low density. Only showing 6 protons per cubic centimeter there. A recent little uptick at Discover. 424 kilometers per second is very nominal for solar wind. Next, our GOES magnetometers here, and nothing too exciting expected to happen with the GOES magnetometers either, as there's no major space weather on the way, just a minor impact, which apparently we forecasted, and we'll have to see what happens, as it's likely to arrive sometime tomorrow. So we'll see what happens. A CME impact tomorrow is going to happen. Next, we'll show the lineup, the GONG data, the GONG-2, the Global Oscillation Network. So there is our heliosphere, and indeed Earth is just snapping into a North Pole-oriented magnetic sector. So crossing a little current sheet there. If you look at the last image, let's see. It looks like Earth's potential field surface source line is in the process of snapping there in the last frame. Keep in mind this data is nearly 2 hours old. So Earth is likely in a North Pole magnetic sector here. That data 1 hour and 37 minutes outdated by the time we made this video already. So let's continue on and speed things up, actually, because we want this onto your screens as soon as possible. So here is our line of sight field plot depicting a lot of fields, like the photosphere magnetism, solar B field, and polar fields. If you don't know which is which, ask us in the comments. Our viewers will help you out. Next, our line of sight coronal hole field plot. We consider this to be a collective effort in many ways to help people understand what's going on with the weather all the way from space down to your doorstep. So this is our line of sight coronal hole field plot. Coronal holes are super important as they show us the solar polar field reversal cycle throughout a solar sunspot cycle. And you can see a lot of coronal holes here. Coronal hole activity picking up exactly as we forecasted for a couple of years. We're behind in coronal holes. You can expect another 20 months of major coronal hole activity. Continuing on to the SDO data. Here is the SDO for the past 24 hours in 211 angstroms, the optimal wavelength to view coronal holes. And things are pretty mild here. None of them are very well defined or very large at the moment, but there is one especially rotating in there in the southeast that is of a North Pole orientation, it looks like. And yes, indeed. All right, so continuing on to sunspots. What do you got? An average number of sunspots right now for this point in the solar cycle. Sunspot number currently at 120. 120, maybe 119 sunspots, close enough. And we'll move on to the flare probability monitor and scoreboard. There you have it. And let's move on to look at sunspots. So once again, folks, there still is a very high likelihood of large solar flares from sunspot 3590, especially as it gets closer and closer to the limb. So don't be surprised in the slightest to see more X-class flares from it. Its simple proximity to the limb increases its likelihood of producing large flares by a significant degree. So in addition to its magnetic orientation, which is still complex, it is becoming more and more likely as it approaches its setting mode there in the northwestern limb. So anyway, continuing on to look at sunspots, here are the data from SDO Continuum. That's what about 120 sunspots looks like, folks. And again, all eyes on that sunspot 3590 in the upper right, the most interesting sunspot of the cycle by many measures, as it has produced the largest solar flare of solar cycle 25 to date. So these are 24-hour continuum images, and let's zoom in as in all the way in. So there's a sweet close-up of sunspot 3590. We'll continue covering it until it sets, and probably even after it rises. We'll expect that one to make a full trip around the sun and come back and rise again. It's kind of likely. So let's switch to the SDO magnetogram, shall we? So it is beta gamma class. Whether or not it's beta gamma delta class at the moment is another story. We'll take a look at it toward the end of the video in high-res magnetogram to figure that out. First, here we've added the 171 angstroms 60-minute running difference images, showing you how the magnetic field lines are associated with the coronal filaments depicted by the 171 angstroms wavelength. And the way that works there, folks, is that the leading portion is white. That would be North Pole magnetism. And then the black portion is trailing South Pole magnetism. Here we've put the raw 171 angstroms wavelength there. And so that sunspot has decayed a little bit. It has lost a little bit of magnetic complexity, but it is still certainly capable of producing X-class flares, again, especially as it gets closer and closer to the limb. So let's move on to look at something a little bit more calm here. Actually, let's look at some of the most wild stuff that happens. Proton flux. Yeah, the proton flux. You got to have it, folks. So there are the past 3 days, and it's flatlined. There ain't no high-energy electrons besides baseline, high-energy protons besides baseline levels. And next is our X-ray flux, and only some C-class intensifications over the past 48 hours, really. So let's take a look at 94 angstroms there, a close-up of sunspot 3590. Ah, yes, sunspot 3590. It's aging like fine wine. Here's an even closer view. These are 24-hour videos in 94 angstroms at 30 frames per second. While we're here, here's a close-up in 131 angstroms, another species of ionized iron with a different number of electrons in its outer shells. 131 angstroms is the hottest of the SDO's AIA wavelengths. Once again, that's a 24-hour video at 30 frames per second. Next, let's take a look at a star chart, shall we? So, that's what's going on over our head right now in Lehigh Valley, Pennsylvania. And, well, something like that. And if you want to find the dog star, the brightest star visible from planet Earth in intrinsic, not intrinsic, in actual, in real light. The brightest star is Sirius, the dog star. And to find it, it's kind of just to the southeast of Orion's belt. So there's Sirius, part of Canis Major, Orion's belt, kind of nearby to the dog star. Next, the solar system forecast. There is where things are today. There's where things will be in a week. Mercury is making its way around to join lonely Earth on this lonely side of the solar system. We've got a crescent waning moon at the moment. And let's take a look at our astronomy photo of the day. And I guess that one needs to be full size, right? Yeah, that's not bad. That is a, quote, supernoval remnant, end quote, which contains a magnetar. Yeah, a rapidly spinning neutron star. And the wavelengths you're depicting here, those are hydrogen in the red-orange and then oxygen in the blue. So I suspect that the neutron star is someplace around where you see most of that blue, as oxygen being more massive takes longer to exit supernoval clouds. That is anticipated to have happened about 40,000 years ago when woolly mammoths, quote, roamed free, end quote. Nicknamed the Spaghetti Nebula. It's pretty sweet. apod.nasa.gov if you want to check it out yourself. And just a quick reminder that we've never seen a star change states. So we've never seen a neutron star formed. We've never seen a star die, for that matter. Of course, there have been some interesting signals associated with accretion disks of galactic cores and things like that, but we've never actually viewed the death or birth of a star that I'm aware of. And if I'm incorrect, let us know in the comments. By all means, I'd be interested in seeing any observations of said stellar phase state changes. Anyway, let's continue on to check out the coronal mass ejection section of the video. So there are today's CMEs, and things have been pretty mild. Let's move on to our LASCO C2 and C3, where there's some missing data. So let's look at some more missing data, and let's just skip ahead to stereo A, because the data there is a little better, but also bad. And what do we have here? Maybe the difference imagery? Will that deliver us? Not really. It's still 6 hours old. So let's look at our custom coronagraphs, which, by the way, are also not helpful. So sorry about that. But if we do see a CME, we'll be able to guess if it's earthly directed just based on its location before even seeing it exit the corona. So let's zoom in a little bit closer here, as there does appear to have been some sort of an event right here south of sunspot 3590. We'll also take a look at filaments. So let's do that next while we're on the topic. So was there a filament here that erupted? And it doesn't look like it. So that's Big Bear, California, actually, instead of Cerro Tololo. And we'll zoom in a little bit closer. Get a little closer, don't be shy. Get a little closer and see if you're gonna scream out, we're all gonna die. No, you're fine. That filament looks like it's still intact, and yeah, looks like things are pretty chill as far as CME impacts. Everybody chill! If you want to name filaments after living people, and by the way, this one right here is definitely suitable of a name. So let's show you how to do it. Just take a screenshot of a thing like this, and then go to the Twitter feed, right? x.com/smashamash and follow the hashtag name that filament. Very simple. And name it after living humans, right? Pretty simple. Name it after your friends, your foes, or even yourself. And follow us over on x.com/smashomash. We're all over the internet as Smashomash. So just whatever. Follow us, don't follow us, do whatever. You'll be missing out on certain content. And whatever you do, folks, don't join a cult. Don't join Heaven's Gate 2.0 or any other cults. It's just Really pathetic. So anyway, here are the last couple of hours of what's going on from the GOES 16 SUVI, GOES 18 SUVI, I should say, and things are pretty chill there as well. Let's move on to our bonus features segment, starting with satellite charging hazards we ain't gotten none except for some minor ones here, where low-energy electrons build up on the outer portion of spacecraft there over places like the Middle East and Eastern Africa. Okay? Next, the GOES electron flux, and it's low. It remains low. It's like an electron shortage. Look at that. It's been going on since December. Oh, my God. If electron shortages get you bunker-worthy, then definitely get in your bunker, because the electron flux has been flatlined. Oh, no. The electron flux is flatlined, folks. Everybody get in your bunkers. Live inside a Faraday cage and eat MREs, because that's going to save you from that low electron flux, right? You're welcome. Pardon my sarcasm. Next, we'll show the ionosphere. How about that? All right. Never mind. It's a space weather dictatorship. We don't care. But there's a diagram to show you what I mean by the ionosphere, and I mean the F layer. The layer where the electron flux is measured. So here it is from Australian Government Bureau of Meteorology, and we can actually switch to this. Keep in mind, folks, if you're viewing this on a mobile device, you can zoom in 8 times with the YouTube app just by, zooming in, using the pinch feature. So, yeah, zoom in 8 times using the YouTube app. Or if you're viewing on a PC, okay, boomer. Just kidding, folks. PCs are epically awesome. They are the ownage. Anyway, so that's the ionosphere. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. And we did have a geomagnetic storm in there, so you're seeing quite a bit of red in the southern hemisphere. That is what you would expect to go on in the ionosphere during a mild geomagnetic storm. So at the end of that, you should see things simmering down. That's usually what happens after they end for many hours. And that is exactly what you're seeing. So cheers. Facts about the ionosphere. Very controversial. It's 2024, so definitely be spooked of the channel and make sure you unsubscribe if you are frightened of facts. We've been talking facts for years and years. And again, terribly sorry about the controversial, spooky facts. And that's, if you're wondering what that is, that's a Toy Story Band-Aid. So, yeah. So next, the Global Ionosphere Nowcast, depicting total electron content and radio frequency expectations. It's the whole atmosphere model, or the Global Ionosphere Nowcast. And let's move on and end this space weather section and do meteorology and get this onto your screens. So there are the magnetic fields and umbrae. Let's see if we see a new sunspot rising here. Not yet. Quick look at sunspot 3590 in full res. There you go. It's still beta gamma class. Is it beta gamma delta class? Not really. Well, I don't know. Not really. I don't like to call it beta gamma delta class, but whatever. Let's move on to meteorology. It's time. Time to show the planet. And it's welcome to the Smash News Network, least busted name in news. Now we're showing the planet, and we're showing sea surface temperature anomalies and surface winds. All right, the Great Lakes are anomalously warm. The North Atlantic is a mixture. Some warm water, some cold water. Hopefully neither of those things spook you. But this is in many ways the pulse of the Northern Hemisphere, at least according to the geologic record. And I won't get into that. It's far too controversial, folks. Facts. Super controversial. So there's the Atlantic Ocean and sea surface temperature anomaly, as well as surface winds. There's the Southern Ocean, Indian Ocean, the Arctic, and let's don't forget the mighty Pacific. That is a beefy body of water. Anyway, here are regularly scheduled meteorology segments, surface winds and jet streams for the planet. There you go. Shout out to our viewers from the east. Shout out to our viewers from the central planet. Jet stream, surface winds. Shout out to our viewers from the west. surface winds, jet streams, clouds and fog for the Americas. It's taco night. Who's having tacos? Taco Tuesday. Who's having tacos? Let us know in the comments. We're having tacos. We're having nachos. Yeah, nachos. Next are, what is that, new snow? Let's look at snow depth. There's the current snow situation. And let's take a brief look at precipitation type. Precipitation type. There you go. As snow is currently falling over many portions of the lower 48. Also some rain over Pennsylvania. Next, our weather.gov map. Weather.gov is where to get your warnings. There are some blizzard warnings on there. That's the orange. Please take heed of blizzard warnings. Do not get caught in a whiteout. You could freeze solid in a certain period of time. Weather.gov is where to get your weather warnings. Next, some forecasts. And I'm back. Ta-da! So there's our pressure and precipitation forecast for the GFS 72-hour model. Accumulated positive snow depth change in inches. Same model, GFS 72-hour. Total accumulated precipitation. And look at the massive amount of precipitation coming to the Pacific Northwest, Washington, and Oregon. Let's cut back to snow once real quick. So lots of heavy snow and rain coming to the Pacific Northwest. And our 72-hour temperature anomaly forecast in degrees Celsius. So a cold wave is going to move through, and then a second heat wave is going to move through, starting in places like Montana and the Dakotas. Temperature anomaly in degrees Celsius there for the 72-hour GFS model. Looking promising for some cycling weather in the coming few days. Ta-dow. Next, our lightning mapper. That's where lightning's been striking for the past, 10 hours. Here's where lightning's been striking for the past, 1 hour. And it looks like we have some terrestrial strikes here in someplace. One of those freaking states. What is that? Illinois. Some lightning in Illinois at the moment. There you go. Southwest of Rochelle, we've got some terrestrial strikes. By the way, folks, remember, never try to sneak up on a dragon in its own lair. You will fail. The dragon might be cross, and it's just unhealthful to do. So don't try to sneak up on a dragon in its own lair. I tell you, because it is the year of the dragon. And I have personal stakes in this. Anyway, here is the U.S. Doppler radar map. We're closing things out with this. Also clouds and fog, and also water vapor. So when your Doppler's unclear, use the water vapor. Here's the recap. The U.S. Doppler radar map. Those ground-based systems depict vertical motion in the air column. This space-based system depicts shortwave radiation emitted by clouds and fog. And this space-based system detects a different portion of the infrared spectrum emitted by all of the water vapor. Anyway, that's where I close this thing out. I'm headed back to the bunker. And while I'm gone, may that solar wind be at your back. While I go back to the bunker again, all the nonsense that I've heard is welling up again. Hurrah.